Good morning, everyone. This is Shauna, and I'm coming to you this week with your check-in for sections 4.2 and 4.3 of geometry. One of the things that you're going to be doing this week is continuing your study of parallelograms. So let me share my screen at this time and show you a little bit of what you're going to be seeing here. So, oops, excuse me. So we have your sides and as you can see, the parallelogram of the kite. Now you already know what a parallelogram is, and you know what a quadrilateral is. So the first theorem that you're going to see is if you have two sides of a quadrilateral that are both equal in measure and parallel, then you have a parallelogram, which is something that you knew from last week. And if two sides, if both pairs of opposite sides are congruent, then you have not necessarily a rectangle, but you have a parallelogram as well. So let's look at, you also have an example here. Determine whether the following quadrilateral is a parallelogram. So we know that we have AB is congruent to DC. So we have one set of congruent sides. And we know that AB is parallel to DC because of this transversal BD and alternate interior angles. So that's going to be a little bit about what this is about. So if you drew two diagonals that were not only bisected, remember that means cut in half into two equal parts. They not only bisected each other, but were equal in length, then we would get a rectangle, okay? So we're also studying rectangles, but besides rectangles, we have kites, and kites are a quadrilateral, okay, so it's four-sided, with exactly two pairs of congruent consecutive sides. Congruent consecutive sides. So AB and BC are consecutive, but they're not congruent, notice. But AB and AD are consecutive, and they are congruent. So that's one pair of consecutive congruent. And you have BC and you have CD, and again, they're consecutive sides and they are congruent. So we have a kite, okay? If all four sides are congruent to each other, obviously, we have a square, not a kite. So there's a couple of more kite theorems in here and some examples for you to follow here. Most of them have to do with kites. Let me go down to this remark. We want to look at something here. So when you construct a house or a bridge or a building or anything that needs extra stability, we brace them with triangles. And triangles add extra stability to the structure, but they also give rise to a particular theorem, and that is the line segment that joins the midpoints of the sides of a triangle is parallel to the third side and has a length equal to 1/2 of the third side. And you might wonder why we're putting this here, but this will become more apparent later on. It is in this section, and it does have a bearing on other materials as well. So just be aware of that this theorem might seem like it's misplaced, but it is at the end of the section, okay? Now, the other section that you're going to be looking at is section 4.3. So let me bring that up on my screen, and then let me share it with you. We're going to be talking about the square and the rhombus in that section. So let me bring it up for you right now. It's still loading. It might take a minute. Rectangles and squares are familiar to you. The rhombus might not be. The rhombus might be a different shape for you. So very quickly, let's head over to the rectangle. A rectangle is a parallelogram with 4 right angles. So once again, we have 4 sides, which makes it a quadrilateral. We have 2 sets of parallel sides, which makes it a parallelogram. But the thing that makes a rectangle different from a parallelogram is the right angle. So a rectangle is a parallelogram, but not every parallelogram is a rectangle, okay? Be careful of that. A rectangle is a special type of parallelogram. And so then we have some corollaries for you coming up, and then we talk about the square. Very familiar. A square is a parallelogram with 4 congruent angles and 4 congruent sides. Opposite sides are parallel. You have 4 right angles. You have 4 congruent sides. Consecutive angles, angles that are next to each other, are supplementary. The diagonals of a square are congruent. They're the same length. The diagonals bisect each other, so the segments that they cut into are equal length. The diagonals are perpendicular, and each diagonal bisects a pair of opposite angles. So when you have a square and you draw the diagonal, the angles that are bisected are equal also, okay? And then we have this thing that might not be as familiar to, called the rhombus, okay? So a rhombus is a parallelogram with 4 congruent sides. Now, here, again, notice the sides are congruent, but it doesn't say the angles are congruent. Now, they could be, because when we have a square, if a rhombus is a parallelogram with 4 congruent sides, then a square is a rhombus. But the difference between a square and a rhombus is, again, the right angles. A square is a rhombus with 4 right angles. So we have some corollaries of the rhombus also, which are very similar to those of the square. And this is an interesting thing that you probably never thought about, but we have the Pythagorean theorem at the end of this. And the reason that it's here is we put a bunch of squares on the sides of a triangle to show you how the Pythagorean theorem is derived. You've used the Pythagorean theorem in algebra. Pythagorean theorem applies to right triangles. So the leg squared plus the leg squared equals the hypotenuse squared. A squared plus B squared equals C squared, or C squared equals A squared plus B squared. It doesn't matter. But again, we derive it with a bunch of squares. Um, so the Pythagorean theorem involves right triangles, and it's just what I told you here. In a right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. Remember this, the straight sides that aren't slanted, the vertical side and the horizontal side are the legs, and the side opposite the right angle is the hypotenuse. And there's a couple of examples of that for you. Um, and it should be fairly straightforward, okay? So I hope that this little review of your slides this week and this little preview of the sections that you're going to be learning has helped you. Be sure to study the PowerPoints. Be sure to look at the textbook. Make sure you know how to do the examples on the slides. Look at the textbook before you look at the homework, and look at the supplemental video content. If you have additional questions when you're doing the homework, please reach out to us so we can help you. And if possible, if you've worked on it, screenshot your work or take a picture of your work and send it to us so we have a sense of what you're doing with the problems and where you may be having some difficulties. Take care, everyone. Stay safe, be well, and I'll talk to you very soon. Bye for now.